Okay, so I've been sent in 2 combinations questions, and I actually think that this one here, when we get to it, I will be controversial and say the answer in the back of the book is wrong, and I'll explain why I think it's wrong, and you can either agree with me or raise a point of order with somebody else you want to check it. Okay, so let's start up here though. A sample of 3 coins is taken at random from a bag containing 8 10-cent pieces and 8 20-cent pieces. All right. Now, this is a little bit odd because we need to think about these as individual, unique 10-cent pieces and 20-cent pieces. So you might think, well, maybe this one's got a different date. Every single one of these have different dates on them. Maybe some of them are scratched. They're unique coins. All right. So, in how many ways can the selection be made? Well, let's imagine first that we can have all 10-cent pieces. Then there would be 8C3 ways of choosing all 10-cent pieces. Then there's 2 10-cent pieces and 1 20-cent piece. So that would be 8C2 by 8C1. And then, of course, you can have 1 10-cent piece and 2 20-cent pieces, and this would actually just be the same value of this in reverse, so 8C1 times 8C2, and as well the reverse of this is just 3 20-cent pieces, which would be 8C3 again. So all of these would need to be added together because each of them are unique possible outcomes for choosing 3 coins. And because they're unique and they can all happen, we're making a total sample space, and we work all those out and add them together. You get 560 possible outcomes for this first one here. Now, I have a problem with this second one. It says find the probability that a particular 10-cent coin will be chosen, and this is the crux, if 2 10-cent and 1 20-cent coins are chosen. Well, to me, that means this is a condition of the probability. So if 2 10-cent coins and 1 20-cent coins are chosen, we're only talking about this here as our restriction. So if I were to make a probability statement, I would have to choose what are the chances of choosing one particular 10-cent piece out of 8C2 times 8C1 possible ways of choosing 2 10-cent and 1 20-cent coins. Now, of course, with this type of question, if we want to see a particular coin makes it in, then we pretend that coin is already in there, and we count the number of different ways that can possibly happen. And so that uses up one of our 2 10-cent piece slots, so we've only got 1 10-cent piece slot, and we've already used a 10-cent piece, so it becomes 7C1, and then we have to multiply it by all the ways we can have the 20-cent piece. Now this, to me, is more accurate, and I think maybe just the maybe she was getting tired, it was getting to the end of the chapter, but I think that gives us a lovely answer, but it's just not the one that is in the back of the book. Now, if somebody wants to give me an alternate answer to that or an alternate process, I'd love to hear it, but I am 100% convinced, well, 99.8% convinced that that is the correct answer and the correct process. Alright, so let's extend down and look at this next one. Sorry if I'm rushing, but I've got to go in a minute. A group of 8 people is chosen at random from a class of 30 students to go on a hike. Now, we're quite comfortable with this one. This is 30C8 to choose in how many ways the group can be selected. So this is just 8 people out of 30 students. So 30C8 is a big number. It's 5,852,925. Let's just block this off a bit so we know what we're doing. This is our answer to A, which is this 30C8. Then we've got 12 teachers choosing 2. So that's just 12C2, 12C2, which is then 66. And really, this is just fairly straightforward calculator work. It's this last one that is being cheeky. All right, Mr. Baldwin's favourite student, that's dodgy. Mr. Baldwin don't have favourite students, dear oh dear, is Paula, even more dodgy. Find the probability that they will both be chosen. Okay, so first off, we need the combination of the students and the teachers. There's 66 possible ways that the teachers can be chosen, but for each one of those possible ways, there's 5,852,925 ways that the students can be chosen. So this huge amount are all the possible ways that teachers and students can be combined. Wow, that's a lot. And so all probability statements are what we want to see happen, dodgy, on what could happen. So, of course, if we have a particular teacher that we're trying to count how many different ways that teacher could be chosen, then we've got to count the teachers that could be arranged around that teacher. So we've used up a teacher, we've got 11 teachers left, and we've used up a slot for that teacher to go on the hike, so there's only one slot left. And we're going to combine that with, now I've used up a student, so 29 students are left and 7 slots are left. And if you just whack this whole ugly thing into your calculator, it simplifies to quite a nice answer. Okay, I hope that was helpful.